Have you ever thought about what it would be like if a robot could just look at you and instantly mirror your exact expression? I mean, your smile, your frown, even that little flicker of surprise. And we're not talking about some pre-programmed party trick. We're talking about a genuine, real-time reflection. Well, what used to be pure science fiction is now a very real engineering breakthrough.
You know, for decades, the whole idea of an emotional robot was kind of treated like a gimmick. We saw these incredibly advanced robots like Sophia, and the general thinking was, yeah, that's impressive, but it's just running a script. The belief was pretty simple. They were just sophisticated puppets, right? Just cycling through a library of pre-programmed faces without any real understanding behind them. But it is time to just throw that old belief right out the window. The game has totally changed. See, the old way was all about simulation, basically a really clever fake. The new reality? It's about functional mirroring, a high-speed, super responsive reflection of actual human emotion.
So let's just make it official. The puppet myth is dead. And what killed it? Well, it was the fusion of two incredibly powerful technologies. Large language models, LLMs, and real-time computer vision. Now, on their own, they're pretty amazing, but when you put them together, oh, they change everything. Now, to be super clear here, this isn't about robots suddenly waking up with consciousness or feeling emotions the way you and I do. That's a whole other can of worms. The real breakthrough here is a solid engineering achievement. It's all about a system that can see, process, and then reflect our emotional states so fast and so accurately that to us it feels completely genuine.
So the big question is, how on earth is this even possible? Well, it's not one single piece of magic. It's actually a system built on 4 distinct but totally interconnected technological pillars. Let's break them down.
The whole thing works a lot like a person, really. It all starts with the eyes and ears, which is all about perception. Then that information gets sent to the brain for reasoning. The brain's decision then gets expressed through the face, in a process they call actuation. And finally, the whole system is constantly learning, adapting, and getting better and better over time.
Okay, let's dig into how this whole thing actually works, starting with those first 2 pillars, perception and reasoning. This is where the robot takes in the world around it and figures out what to do next. So the first pillar is called multimodal perception. And multimodal is just a fancy way of saying it's using multiple senses at the same time. This isn't just a camera watching your face, it's a system that's also listening to your words, the tone of your voice, and even sensing the context of the room you're in, all at once.
And just how detailed is this perception we're talking about? Well, when the robot sees your face, its vision system isn't just looking for a simple smile or a frown. No, it is tracking 468 distinct facial landmarks in real time. That is a staggering amount of data, capturing every tiny little micro-expression. And it does all of this at a blinding speed. Every 33 milliseconds, the system analyzes all 468 of those points and creates something called an emotion embedding. You can think of it like a unique digital fingerprint of your emotional state in that exact moment. And it's doing this 30 times every single second.
So, how accurate is it? I mean, really. On standard academic tests, this system scores between 94 and 97%. It's so tough it can pull this off even in tricky situations, like in low light, or say if your hand is kind of covering your face.
Okay, so the robot has all this rich emotional data. What's next? Well, that brings us to pillar 2, the brain, which is powered by a large language model. The LLM takes that emotion fingerprint, it combines it with the words you're actually saying, and it instantly figures out the best way to respond. And this thinking process is ridiculously fast. The LLM generates what's called a target expression vector, which are basically the instructions for what face to make, in under 80 milliseconds. So the robot sees you, it understands, and it decides how to react, all in a tiny fraction of a second.
All right, so the robot has seen your emotion, it's decided how to respond. Now what? Time for the final 2 pillars, actually making the face and then learning from that interaction so it gets even better the next time. Pillar 3 is real-time facial actuation. This is where the digital response becomes physical. Those instructions from the LLM get sent to anywhere from 24 to 42 tiny little micromotors, or servos, inside the robot's face. These motors pull and shape a soft silicone skin to create these incredibly fluid and natural expressions, which is key to avoiding that creepy, uncanny valley effect.
So let's put it all together. From the instant the camera sees your face, to the brain processing it, to the face actually moving, how long do you think that takes?
The whole end-to-end process is less than 120 milliseconds. That is literally faster than you can blink.
And that brings us to the fourth and final pillar, which honestly might be the most important one for the future: closed-loop adaptation. See, the robot isn't static. It learns. It uses a reinforcement learning system to get feedback from your reactions. It actually watches to see if you mirror its expression back, and it uses that info to improve its responses with every single interaction, becoming more personalized to you over time.
So, we have this absolutely incredible technology, but what does it really mean for us? Why is this such a big deal? Let's take a look at the real-world impact.
The applications here are just huge. I mean, think about healthcare. Imagine a companion robot that can sense a patient's anxiety and offer a genuinely reassuring expression. Or in education, a tutor that knows if a student is bored or confused and can change its teaching style on the fly. Heck, even in your car, an interface that understands if you're stressed or tired. This isn't just theory. This tech is being built into these systems right now.
And that right there, that is the fundamental shift. We are moving beyond thinking about robots as just simple tools, like a vacuum cleaner or a factory arm. This technology is transforming them into something completely new, emotionally resonant partners that can engage with us on a much more human level. Which leaves us with a final and pretty fascinating question to chew on. If a machine, just a collection of code and motors, can mirror your happiness and your sadness so perfectly that it feels absolutely real to you, what does that do to our definition of what genuine even means? It's a pretty wild question, and it's one we're all going to be facing a lot sooner than we think.